Good morning. All right, so here we go. We are talking about the greenhouse effect, what it actually is, what causes it, and then what are the consequences of basically tampering with this natural effect. So the symbols here, you're going to see a lot of pictures in this slideshow, and I want you to think about each one and how it represents um, the aspects that we're talking about in the notes at that point in time. So obviously, right here, we're looking at a couple of pictures um, that have some significance. The one on your, I guess, be your left side, showing that there's just melting that continues to happen as the effect of greenhouse um, warming is increased by our human impacts. And then on the right, some of the ways in which we are actually impacting that process. All right, so what is the greenhouse effect exactly? The greenhouse effect is when light passes through the atmosphere. This light comes from the sun. Obviously, light is the what we learned about. I hope you learned about your freshman year. The electromagnetic radiation. So you have that electromagnetic spectrum. So there's a lot of different kinds of light. We see visible light, but on either side of that, there's actually more than just what we see in terms of wavelength. And so this energy is coming into the earth all the time. Um, we see the visible aspect that's coming through, but all of it is coming through. Well, most of it. We'll talk about some of it that gets filtered out, but most of it is coming all the way through there. It passes through the atmosphere from the sun. That solar energy warms the land and the oceans because it's absorbed by the molecules that are at the surface of the earth. So um, we know that the color, I want you to think about that the color of the earth makes a difference in how much energy is actually absorbed. It's the same way that, like, when you go outside, the color of clothing you're wearing or the color of your hair can actually um, be comfortable, a little more comfortable because it can reflect more light. So it's the same kind of thing that the solar energy warms the land and the oceans. It's absorbed by those molecules. Well, it doesn't stay there, right? So everything has a specific heat. Once it takes on a certain amount of energy, it starts re-radiating that energy. So once the earth has taken on all it can, it starts to re-radiate that, and heat from the earth's surface is then re-radiated outward toward space as long wave radiation or infrared radiation. But infrared radiation doesn't have quite as much energy as that visible light that's come and kind of, or even the UV. But it's come in, it's warmed things up, and when it slows down once it heads back out. So it doesn't quite have enough to get out sometimes, and the atmosphere doesn't let that long wave radiation pass through as easily. It's trapped here, and really what it is that wavelength is longer, and so it has more. Um, Opportunity to run into things and get reabsorbed and reflected. And so it's just it gets trapped here, it stays here. That's good for us though. The greenhouse effect is why we can actually live on the earth. But we also have affected this greenhouse effect. So naturally on earth, there are gases that will trap heat. That's why we can actually live here. Humans are adding to those gases in the atmosphere, and we enhance the natural greenhouse effect. Greenhouse gases that may be part of that, what we're putting into the air as far as this effect. But the greenhouse gases that are warming the atmosphere: water vapor, carbon dioxide, nitrous oxide, methane, and then in smaller amounts of chlorofluorocarbons. Ozone definitely warms the atmosphere, but we'll talk about how that works later. What we call greenhouse gases, GHGs, they actually make up less than 1% of the Earth's atmosphere. However, they are powerful in their effect. So here's a diagram. I want you to take some time. So actually would like you to pause the video here, really take time to study and to get this onto your notes. Um, so what I mean is basically, like, you have that first illustration and you can go ahead and take a moment to put descriptions around that and to add onto your notes using this diagram, and making sure that this becomes part of your notes. So you have the one that's not labeled, you should be labeling that and go ahead and put these, like, little captions in there as well. Okay, so like I said, pause and get that done. All right, so once you unpause, we're going to talk about why these actions can be like our human actions, why those actions can actually cause damage. One of the things we're afraid of within the scientific community, just kind of is just like, when is it too far? And so we're going to talk about positive and negative feedback loops and how these gases work to either stabilize or destabilize the temperature on Earth. And so we have to talk about these two situations here, okay? So a positive feedback loop is when a stimulus feeds into the response of a system. So, like that greenhouse gases, right? The greenhouse gases warm the earth. When the earth is warmed, that helps to increases water vapor. So when the surface of the earth has a lot of oceans on it, and when it's warm, the water vapor will hang around in the air, so it evaporates off of the surface of the ocean, and you get increased water vapor in the atmosphere. Well, that warms the atmosphere, which increases the overall warming and can increase evaporation, which can increase warming, which can increase evaporation. Till when, right? Well, in this case, oftentimes until clouds form. And then clouds have a reflective capacity. And so when we talked about earlier in the presentation, it talked about those insolation, incoming solar radiation, insolation. So insolation is taking place, it's coming in, and it will come all the way to the earth and it will warm the earth. Well, if there's a cloud layer, it's going to bounce away. And it's more likely that it's going to reflect off of a white surface. So the tops of the clouds are white and it will actually reflect instead of being absorbed. And in that case, now we switch into what we would refer to as a negative feedback loop, where the clouds are going to help to cool the atmosphere and just bring that whole warming system down a little bit. All right, so positive feedback loop, this is the one example. Adding carbon dioxide to the atmosphere will tend to warm the atmosphere. So we're adding on to that capacity. And here's where the anthropogenic, what we call the human caused, human, pogenic, genic means starting. So this is the human start of this, is where when we add to the carbon dioxide that's already in the air, we push the positive feedback loop aspect, because there's more warming that causes the surface to evaporate, become water vapor. And since that water vapor is a greenhouse gas, that can tend to warm the atmosphere even more. Whereas in nature, there's a balance, and the warming of the radiation coming in will cause an increase in cloud formation, and then some of that water will condense and contribute to reflection, and some of it will trap some heat in the atmosphere. But that reflection will actually help cool the planet. And so it brings the warming back down. Some examples of positive and negative feedback loops in other aspects of your life, because we want you to understand these principles as systems that are part of the scientific theories that you need to understand. One of the easiest ones is to talk about a sneeze. Okay, so if I get a little tickle in my nose, I get a sensation, and I may actually breathe in a little bit harder. Well, that will stimulate or causes some kind of stimulation. Maybe I got like a little cat hair or something in there, right? The cat hair moves when I breathe in a little, and then it tickles and it causes me to breathe in more. Well, now the hair tickles my nose more, and then it causes me to breathe in a little bit more violently, and then my body will sneeze. So a positive feedback loop can be found in a lot of places in nature, where there needs to be some kind of finishing effect. So pressure buildup, heating, and volcanic eruption, right? The pressure and heat creates gases, which creates more pressure, which the higher pressure creates more heat, which creates more gases, and then eventually you have an eruption. So a positive feedback loop can happen in living and in non-living settings, but it is definitely a principle that we use to explain phenomenon. Like we understand that this model works. This is how the world works, and that a positive feedback loop can kind of be runaway change until a point, until there's some kind of event. Well, when we look at runaway heating, we don't necessarily want to increase the aspect of this feedback loop that is the positive side, where I don't mean good when I say positive, I mean additive. Okay, so we understand that a feedback loop from the positive feedback or within the positive feedback model will increase an output until there is some kind of event. So the input added is additively, it's increasing or even sometimes exponentially increasing the output until there is some kind of breakdown, or like the sneeze, like that relieves that situation. A negative feedback loop is more for maintenance around a set point. So the classic example is a non-living example. It is temperature on a thermostat. We use like a air conditioner as the example, and this works in your body in a lot of ways, that you maintain levels of a lot of different things in your body because of negative feedback loops. But this makes it easy to understand when we have this non-living example. So your thermostat is at a set temperature, and when the temperature rises above that, the thermostat kicks on the air conditioner and it cools the air, and then the temperature comes back down. Well, once it's cool enough, then that air conditioner can turn off. Then the warming begins to happen because outside, it's hot, and the air conditioner comes back on, and then it turns back off, and it comes back on, and it turns back off, and it comes back on, and it turns back off. Well, this just rotates around a set point. This is a negative feedback loop model, and that system is like what I was describing when the cool or the warming causes water vapor, but then the water vapor condenses, and that causes clouds, and then the clouds help with cooling. So there are both of these systems at work constantly in so many different aspects of the atmosphere, not just with CO2, but with all of the other gases. So we have these very finely tuned balances. It's a system that is based on equilibrium. The energy coming in, we keep just enough of it to keep the right temperature. Well, if we keep too much, the temperature rises. What causes keeping too much of the energy within the surface? These gases. So it becomes incredibly impactful when we increase certain gases because they have a very profound effect on the temperature of the surface of the earth.